too.
Okay. Could you scroll up to the data set there?
Yeah.
All right. Now, what technology are you going to use on like a test? Is it your
We have a
calculator?
we have a table, like we have a appendix table that we look at. So we have like this, but
Oh, that's good.
we
That
have a
does help.
physical appendix table like
Okay.
this.
All right. Yeah, let me grab the other question. I'm sorry, I have to ask a few more questions. So could you go down to the next one? You said, I guess, 18 you also want us to look at?
Yeah.
Okay. One of the things that I need to know to be able to help you here, because you're in this part of the course where I don't know whether you're using Z or T distributions. So,
We do Z
do
scores and T scores.
right. So for example, both of these appear to be T distributions because the population standard deviation is not known,
Okay.
although that is an assumption I am making. But do you mind if you click on practice another,
Mhm.
does it give you the either one of these? If
It'll
you
show
put in
you
just,
what it looks like. Yeah.
will it show you the solution so I can see what you're doing for
Yeah.
T?
Like say if I use something like this, it's gonna look like that.
Oh, it doesn't give you the show solution. Okay.
Yeah.
All right, that's fine. I would still work with this as is. Okay. Yeah, we got enough here to get started.
Okay, great.
All right. Um, so for question number one,
Mhm.
you have to calculate the point estimate X bar. You calculated X bar as 21. That's fine.
Mhm.
You
Yeah.
also need S, which you can get from a lot of places. You know, your calculator, online calculator. You need the standard deviation. So how have you been doing that? Um, just
Standard
curious.
deviation, we do it just by hand, like and like
Well,
using
that's
a physical calculator.
okay. Like, are you using the built-in calculation for that, or just doing the actual? Like,
The
there's a built-in calculation for it, which I could show you if you would like.
yeah, I could use that, but uh we just do it on the calculator, like in our physical calculator.
Okay, so this is 2.608, the standard deviation I got for this.
Mhm.
Hopefully yours is similar, however you're doing it.
Oh wait, yeah, we don't do it on the calculator then. I don't know how we
We can get that. Let's get these questions answered first. So your n is 6, which
right.
means your degrees of freedom is n minus 1 or 6 minus 1, which is 5.
Yeah.
So when you want an 80% confidence interval, your C is 0.8.
Mhm.
Alpha is 1 minus C. So that's 1 minus 0.8, which is 0.2.
Mhm.
And then when you cut it in half,
Mhm.
that's 0.1.
Right.
So what that means graphically is there's 10% in each tail, zero point
Mhm.
0.1 and 0.1.
Yeah.
So in your T table, you're looking for T of 0.1, degrees of freedom 5. So I can help you kind of manipulate that, but
So I think I would go to my appendix table and then I would scroll all the way down and look for it like on the table, like
yeah,
at
I,
that
I can
point.
help. I can help you look for that, but it ends up being 1.476, most
Mhm.
likely. So you need that value to do the confidence interval here
Okay,
for the
yeah,
80%.
I'll share my screen again just so like I know where to like look because this is where I'm like really stuck on. I missed a few steps and like
Okay, so degrees of freedom 5. Look at that row with 5 in it.
5 is here,
Okay, and then you go across until you see 0.1 in the tail. This
which
is the wrong table. You're in the chi-square distribution table. This is the wrong one.
okay, so this is
You go up. It's after the normal one. Yep, there you go. Keep going up, 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 up. One more page right there. Boom. All right,
mhm,
go to degrees of, see how it says T distribution there, table 2, T distribution at the top.
yeah, table
Yeah,
2.
that's how you know you're in the right one. I know it's like there's a lot of tables. So row 5, 5 degrees of freedom. If you go over to 0.1, see that's 1.476,
Yes,
which is the number I just gave you.
right.
So you
Got
need
it.
to be able to get that number.
Okay, got it.
And there's more than that, but
Uh,
we'll settle on that for the first one here.
okay.
Okay. So the confidence interval calculation is X bar plus or minus your T alpha degrees of freedom value times S over the square root of N.
Mm,
So you now have all of these values.
mm,
Your X bar was 21. The T value is 1.476. Your
mm,
S is what I calculated, the 2.608,
mm.
and then it's over the square root of 6. So this is really two calculations. It's 21 plus all this, 21 minus
All this, right.
all this.
I figured how to do. And then I also got stumped on when you're simplifying 2.608 over the square root of 6. How do we know how many decimal places to multiply it by 1.476?
I just went out to 3 because this was 3. I mean, you should go
Um,
out as many as it wants you to.
mhm. Okay.
I don't know if that is Trish, but you need to go out as many as you can.
And so just like three, typically.
3, 4. So
Okay.
I don't know what the final answer wants you to round it to. I didn't look that close. Let me look.
Three decimal places.
All right.
Yeah.
So I might have wanted to go out a little further on that one. I don't think
Um,
it'll make much difference, but these are the two limits, 19.428 and then 22.572.
yeah. And this was oops, uh this was number which one? 17 that we
Yeah,
yeah.
this is 17.
Yeah. And this is for the 80% confidence
Yes.
interval. Yes.
Yes.
Okay, so I'm gonna type that in. Uh, could you scroll down again? I didn't write it down.
Of course. Of
Yeah.
course.
So it's gonna be 19.428. And then I won't submit it yet just because I have 3 attempts. Uh,
Okay.
or I guess I have yeah, I have one. Actually, I have one remaining for this one. Okay. So I'll wait till I submit part C.
Okay. Um, keep in mind they're independent, but I
Yeah.
understand. Yeah. So for this
Oh,
one,
are
it's a nine. But
they are independent? I didn't know that. For
well,
my
it's supposed to
one.
be, but don't trust me on that. I don't want to mess you up on that. 98% confidence interval. So
Mhm,
what that means, C is 0.98, alpha is 1 minus C, which is 0.02.
mhm,
You're dividing it by 2, so now you want 0.01.
mhm,
So you're looking for T 0.01 degrees of freedom 5.
mhm.
So maybe look for that value
Yeah.
in the table if you want. You should see 3.365.
So get it. Wait, so this time the 0.1, that's gonna be the X value, like the
That's
Z
that's the
value.
that's the column. The column you're in. It's
Um,
row 5, 5 degrees of freedom.
scrolling down. Yeah, row 5 and then 0. I'm still reading it wrong. Uh,
All right, go ahead and share your screen if you want.
yeah, I'm iffy on this because this is where I've been missing a lot of these
So
steps.
row 5, and then just go over to where it says 0.01. You're in the 0.1. Keep going to the right 0.01. There you go, 3.365.
Got it. Okay. 2.065. Okay, got it.
All right.
Mhm.
So then the actual calculation, let me go ahead and share my screen here, is the same as the other.
Mhm.
It's just the only thing you're changing is this critical value right here.
Which is just gonna be
Which is 3.365.
mhm.
Which course is this? Is this ECN 211,
Uh,
212,
it's 221.
221? Yeah. All right. So 3.365. All right, so that's 17.417.
And
All
then
right, and then The other thing here is that we can actually do this in the calculator completely,
Mhm.
fully. T83, we just enter the data and then calculate it. Would you
Okay.
like us to do that?
Yeah, it'd be nice to learn. Uh, yeah, we haven't done that yet. We don't really use the calculator.
Okay, well, that's only if you're gonna be allowed to use it. If you're not allowed to use it, like I don't want to give you like the
I
magic, the
honestly
secret
think
sauce.
we're just allowed to use the tape, like the physical
Yeah,
tables.
then what I'm suggesting will be no benefit to you.
Yeah,
So I
yeah,
don't want to do that.
yeah.
Okay.
Try this out and yeah, like I had close numbers, but I just messed up some of the calculations, or I wasn't sure what I was doing, but I have them submit it this time and see. 428 D. Let's see. Okay, well, it still did not take that. That's frustrating.
Right, so that's where I'm gonna not. What I don't know is like maybe they want you to use Z here.
Yeah, here, I'll
Uh,
share. It's just
and
one. Hold up. Yeah, it was just one.
so yeah, so that's maybe where you go to your instructor and you ask for credit,
Yeah,
and
because
that's just a small rounding thing. That might have been the standard deviation not going out far enough.
yeah.
I don't
Yeah,
know. That's
yeah, I
pretty.
don't know. It's pretty frustrating because it's like super similar, and even my previous ones, I feel like it wasn't. Well, at first it was, but yeah, I will definitely email this to him.
Yeah, screenshot's pretty clear. Like, hey,
Yeah,
this is the same.
same. Yeah, I just took a screenshot. I'll probably email that to him. Okay.
All right,
Um,
so in this new problem here, I'll go ahead and share my screen. Be very similar.
or yes.
I'll make your screen. All right, so the when you read the words here, it says that the average is 16,
Mhm.
S is 3.4, and N is 256. So when you look at your E table,
Yeah,
it probably does not go down to 255, but I'm not sure. Could you check if yours does?
yeah. The appendix table. Yeah.
Yeah.
See.
The reason I'm asking is it like technology does go down to 255, but your table might not.
Yeah, for it only goes down to 100 for degrees of freedom. Yeah.
So this is where again, like it depends on the instructor, depends on the course. Some instructors are like, because your N is so high, you just assume it's normally distributed to Z.
Mhm.
Um, However, technology will allow you to calculate um, that critical value. Um, so when it says 95% confidence interval, again, the alpha is 1 minus C. So that's 0.05. When you divide it by 2, that's 0.025. So we're looking for a T of 0.025 comma 255.
Technologies, I'm gonna go look at that.
And if you use technology, it ends up being 1.969. Now, if you just used a pure normal distribution,
Mhm.
your Z of 0.025 is 1.96.
Right, right.
So you can see that there's not a lot different, but I mean, could be an issue.
Sure, yeah.
So I'm not really sure what to suggest, but the confidence interval here is 16 plus or minus
Mhm.
1.969
Mhm.
times 3.4 over the square root of 256. So I'm gonna do that
Yeah,
calculation now.
I was just checking my work. The first time I did 16 plus 1.96, but that was not correct. So I think maybe yeah, the 1.969 then over 256. Okay.
So I get 15.582
Mhm.
and then 16.418. I mean, full disclosure, this is a rounded value. So like if I were doing this in a real thing for a real person, real, real like
Mm.
actual application, I wouldn't round this number at all. So that could
Yeah,
also be a problem, but I don't know, maybe try these.
yeah, I'll try this and see how that works. Oh yeah, that took that one. That was correct.
All right. So for part B, they're telling you that N is now 65,
Mhm.
which means your degrees of freedom is 65 minus one or 64.
Mhm.
So your T value of 0.025 comma 64, you're going to go to row 64 where N is 64 and then look for the column where it says 0.025.
Okay, I'm doing that. So 64, 0, which is 1.998.
That is what I got as well.
I agree.
So it's the exact same calculation, except instead of that T, that changes, and then the N value changes. So your N is now 65, 1.998.
Oh, when you type this into a calculator, do you just you do the ones like the left side first, so like 1.998, or did you have to do it individually first, like solve the 3.4 over 65?
Here's how I'm entering it. You can enter it all in one step.
Okay. Oh, okay. So I'll do the same
Yeah,
then.
with appropriate parentheses, like your calculator knows to multiply and divide, then add.
Mhm. Okay, I got 16.8425.
Okay, that's the upper bound, and then do the lower as well.
I'll do that. 16.
I didn't write it down. I might have a slightly different value.
Yeah. Yeah. Okay. Let's see. Divided by 7. And then the lower one, I got 15.157.
Okay,
Yep, perfect. So I'm gonna type that in. So, yep, that took that. That was great. Okay, great.
excellent.
Perfect. Yeah, this technology, it's just iffy. I don't like that he only gives us 3 attempts because like these numbers have just been so similar in value. Um, I guess I'm
Yeah.
gonna like one more thing to look at like really quick.
Okay.
Because I guess I am still kind of stuck on
Go ahead and
actually,
share your screen and
yeah,
take a look.
yeah, let me grab something really quick. Uh I'm just grabbing it from the notes. Actually, I don't know how to formulate my question. Okay.
Do the best you can.
Yeah. I'm looking at something like here, I'm gonna go all the way down.
So I've seen all these questions before.
Oh, okay.
If
Are you
you
helping other students with
no,
this?
no, it's the same. It's the same. I mean, they give you the same questions all
Yeah.
every year.
Or I think it's my question is like, because we're gonna have physical tables and on the test, and I'm so used to using the technology. So like we use something like this.
Yeah.
So say if I'm like looking for a z-score of a value, how do I like pinpoint it on a physical table, like row and column wise? So say if I'm trying to like find the probability of like two numbers or like two tails.
Yeah. Go back to your tables there in that other
Yeah,
tab, Appendix B.
yeah,
All right. So could you just magnify this a couple more
yeah,
times for me? I appreciate it.
yeah.
Okay. So let's say you did a calculation and you got a Z of minus 2.54.
Uh-huh. 2 point.
That means you're in that minus 2.5 row.
Mhm.
And you go over to 0.04 column, 0.055.
5, which
That's the area in the left tail.
left tail because it's negative, but
Yeah.
it's also on the side. But if it's on the right, is it the one minus the value and I go to the other table?
That is one way to do it. There's a number of ways to do it.
Right. That's
So
what I'm
like, yeah,
yeah.
let's say you got a Z of like 2.38. Can you go to
Mhm.
2.38 in your
Yeah.
table?
Yeah, it's like the positives. This would
Yeah,
be, yeah.
there you go. So 2.38,
Mhm.
which column is that?
I'll zoom out. This is a
So it's the second one from the end there, 2.38.
like here. This well,
Yeah.
this is a
That's,
row.
yep, 2.3, and then go over to the column for 08,
Oh
point oh
eight.
eight.
Yeah, then you'd go all the way here. Point nine nine
Okay,
one.
so if you wanted the area in the right tail, that number is left tail.
Mm-hmm.
So you would subtract that from one.
One. Got it. Okay.
Okay. Where it gets more difficult is if you want the between area between two Z values.
Mhm.
That requires you to get both areas and then subtract.
Subtract them. Okay, got it.
Yeah.
From each other or
Yes. The
okay.
larger minus smaller.
Okay.
But the table always gives left tail. That's what you have to remember. That's what the picture is supposed to
Right.
convey,
Table. Mhm.
which it doesn't. But it
But if
um
it is a positive value, does that mean right side? It's always going to be the right?
no,
No?
no.
Okay.
It depends on your hypothesis test,
Okay.
which I don't know if you've gotten into yet. You should have if you're doing confidence intervals. Like if you want to know if something has gotten bigger, it's right tail,
Yeah.
smaller, it's left tail,
Yeah, we covered
changes
that.
is two-tailed.
Mhm. Okay. Okay. Yeah, I guess that answered my question. That makes sense. Yeah.
Those questions that you showed me, two tabs over, maybe you closed it. From what students have told me, the tests are really similar to it. Maybe not
Uh,
that one. That one, yeah, in your
yeah.
Canvas there.
Yeah.
They've said it's like they just pull from that. So I would work on those.
Yeah, that's my plan for tonight. I've been working on this today. I was just completely stunned. I didn't know if you did business stats, but I
Yeah, I help with almost everything math related. Now you got to be creative, but you could actually find I don't remember who it was.
Mhm.
So I've helped students with exactly these questions,
Mhm.
and I have no idea who their names were because they. So if you want to do a search on my YouTube channel for like college probability and statistics,
Yeah,
you may be able to find the
some videos on that.
and the other thing you might do is like, so we're in obviously like last year around this time in October, there would be a good time to look,
Right.
end of October, ish, but also where would that put us in the spring? Um, mm, March,
Mhm.
like sometime in March
Okay.
would have been also when I would have helped students with this.
Okay, perfect. I will definitely look at those tonight because yeah, my exam is tomorrow.
All right. They're also all on, Course Hero and Jag and all that too. So also
Yeah.
consider that.
Okay, great. Thank you so much then.
Yeah. Is there anything else I can help you with?
Yeah, that was it. Thank you so
All
much.
right. Great. Let me go ahead and just stop right here and